And number 6, here's this equation. Here's another one. What's the value of this expression? We know that this is a clue. Anytime they ask you for an expression on the test, they're telling you it's going to be easier and faster to get that directly rather than solving for A and B individually. So always take the clue. So we want to try to get a common base over here to be able to get rid of the x. It requires us to know what we do when we divide what we do to the exponent. A simple example I give sometimes is I'll ask people, what's x to the 7 over x to the 2? Well, clearly those 2 on the bottom are going to cancel out 2 of the ones up top, and you get x to the 5th. That's a way to remember that when you divide, you subtract the exponent. So over here, it's going to be x to the a squared minus b squared equals x to the 20. You can now drop the bases and bring down the exponent. And so together with a plus b equals 4, that's technically a system you can solve, but it's kind of a mess. If you do substitution, you'll end up having to factor. It takes 10 steps. The shortcut is to see how can you get an a minus b all at once. And then it comes by noticing that we got a difference of squares over here that we can factor. A little unusual that the second one's a variable, but we can deal with it. So that's that classic difference of squares. So that creates that a minus b that we want to solve for. If only we knew what a plus b equaled, then we could get there. And notice they give us that exact value. So you can divide the 4 and you get that a minus b is 5. Individually, a and b are messy fractions, but notice that difference we're trying to find was a nice round number. So always take the clue is the deal.